Hello and welcome to podcast.init, the podcast about Python and the people who make it great. You can subscribe to our show on iTunes, Stitcher, TuneIn Radio, or add our RSS feed to your podcatcher of choice. You can also follow us on Twitter or Google+, and please give us feedback. You can leave a review on iTunes to help other people find the show, send us a tweet or an email, leave us a message on Google+, or our show notes, and you can also join our Discourse forum at discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, and propose show ideas. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. For details on how to support the show, you can visit our site at pythonpodcast.com. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. I would also like to thank Hired, a job marketplace for developers and designers, for sponsoring this episode of podcast.init. Use the link hired.com/podcastinit to double your signing bonus. Coming up in Boston on May 21st and 22nd is the Open Data Science Conference. So if you are in the area and you're interested in learning about how Python can be used in the areas of data science, then you should check it out. You can use the discount code EP for 20% off your ticket. That's odsc.com. Today we are interviewing Jacques de Hooge about his work on the Transcrypt project. Jacques, could you introduce yourself, please?
Yes, okay, I will. Well, I'm a software developer ever since I was 15. My father worked with computers shortly after the Second World War, and I've been programming all my life. That's part of my job. I make technical computer programs, so real-time control systems, and also some cardiology software for medical imaging. And I give lectures at the Rotterdam Academy part-time, about 30% of my time. And the rest of my time I spend making open source software.
And how did you get introduced to Python?
Oh, it's a funny story. I was a quality manager with Fugro, that's a worldwide engineering firm. And there was this guy, William Chesters, from Great Britain. He was a very intelligent guy, and I was making a user interface in C++ with scripting possibilities. And he came to me and he said, "Jacques, you're implementing Python in C++. And I said, "Python, what's that?" I said, "Well, take a look." And I took a look, and it turned out to be a runtime type language, scripting language. And I said, I was a quality manager, so I said, no way that we will use this language in this company, because it will become a mess if we don't have strict typing. So I was very much opposed to introducing Python, but still I tried it a little bit, and a little bit more, and a little bit more. And well, it didn't take long before I was amazed and very much convinced of its power, because it's true that sometimes I miss the strict typing, but it's so expressive and so brief, and the data structures are so powerful that, well, it has saved me a lot of time. So that was my introduction to Python.
And you mentioned that you like to do some open source work, which brings us to the Transcrypt project. And I'm wondering if you can describe what Transcrypt is and what inspired you to create it.
Yes, well, it is a Python to JavaScript compiler. It's not new, there are several of them. And it allows you to run a large, syntactically and semantically faithful subset of Python 3.5 in your browser. Well, there are more products that do that. But I think the special thing is that while it has implemented a large part of Python 3.5, the code that is produced, the JavaScript code, is very lean and very readable and very debuggable. So that is what it is, actually. And I've programmed a lot using Django, and I always longed to be able to use Python on the client side as well. And I had an upcoming project where a lot of client programming had to be done. So I looked into what was there already. And, well, there are many transpilers, Python to JavaScript compilers. There are, for instance, PyPyGS, which is really generating C code and is running on top of ASM.js, which is, well, very powerful, but also a bulky download. One side of the spectrum, and then you've got RapidScript on the other side of the spectrum, which is a thin layer around JavaScript and misses some features that I wanted in. Some people will disagree. I like multiple inheritance, for instance. I know that Java programmers don't care. James Gosling doesn't care. I do care about multiple inheritance. I'm from the C++ world. And, well, I started out using RapidScript, and I liked it. But when I was using it, I missed some things, especially the multiple inheritance, bound function pointer assignments, things like that. And, well, I decided that there was a room for another product. And all my life, I liked making interpreters, compilers, stuff like that. I've made a Modular 2 interpreter in the old days. So, well, I thought this may be fun. And I came across the AST module of Python. And what I wanted to do is to start out from the Python end of things. I mean, if I take, for instance, RapidScript, it starts out from the JavaScript side, using Node.js and things like that. I wanted this to be a Python thing. I wanted this to be distributed via PyPI. I wanted a pure Python syntax, so using the Python parser, stuff like that. So I set out, and it was it wasn't very serious. I put on the website, don't use this because it may go away any minute. But when I was programming it, actually when I made a start, it turned out to be easier than I thought. And, well, there were some hard parts, but I started to like it, and it became more and more serious. And I was amazed what you could implement in a still generating very compact source code. So I decided that it was serious after all, and I reserved a URL for it, transcrypt.org, and well, it became a real project in that way.
And where did you get the name from?
Well, to transcribe, that's what monks did. They couldn't make a photocopy, so they took one of those big codexes and they wrote it down by hand. I've tried to program multiple inheritance directly in JavaScript, but I don't like it. So how I see it is that the transcription is made as a kind of compilation from Transcrypt to JavaScript. So that's where the name comes from.
So I like that you decided to embrace the web environment by calling into JavaScript libraries. What are some of the challenges that you encountered while creating that functionality?
Python is famous for its libraries. It's batteries included thing. But I realized that for the web, you cannot simply copy or re-implement the desktop libraries of Python. The demands made are very different. For the web, good looks are important. Look to all this jQuery, GUI stuff. And many things have been made. There's a very large body of high-quality libraries for JavaScript, actually. I don't know exactly how people succeed in writing such good libraries in such a language, but okay, they're there. And it's an illusion that you can bypass that and redo that in Python. So I felt from the beginning, if this is to be taken serious, it has to gel really well with things like jQuery and, well, all the other stuff that's there, the beautiful stuff that's there for the web. So, well, what I encountered there were a few problems. One of the problems that the JavaScript community doesn't particularly care about, it seems, are namespace pollution and name clashes. Well, there are solutions emerging now, but I mean, there's still no decent module system, for instance. And, well, I hate that. I hate it when I make a program and some new library comes around and I have to change my variable names, for instance. So I try to come up with an encapsulation mechanism so that you can use a JavaScript library that normally has its stuff in the global namespace. You can encapsulate it so that, viewed from Python, it is in the module namespace. That was one of the problems. Another problem was in the data structures. There are broadly two ways to solve the problem of having Python data structures alongside JavaScript data structures. The most dogmatic solution is that you make separate data structures in Python. I mean, that means that a Python dictionary is something quite different from a JavaScript object, and a Python list will be something totally different from a JavaScript array. But if you do that, you will have to convert, and you'll have to write a lot of code, which all has to be downloaded to the client to run it. On the other hand, you have the people who just say, well, an array is almost a list, so we add some methods, and then we add some Python methods, and then an array will be a list. But that's not without problems, because, for instance, an array has a sort method in JavaScript, and a list has also a sort method in Python, but those two are different. The parameters are interpreted differently. So what I did is come up with a concept of pragmas, which are compiler directives, and one of the pragmas is the alias pragma. And when I say sort in Python, this is translated to a py_sort in JavaScript. So I can enrich the native JavaScript types with extra methods without causing any name clashes and without causing any code bloat or delay. That was an important discovery that it could do that. And then there was the new statement. In Python, you don't have to say new. You just call the constructor and things are instantiated. Now, what you can do is encapsulate every JavaScript new in every library, and then you don't have to call new anymore. It is possible in Transcrypt, you can do that. But since there are so many libraries and they're growing and they're changing, I don't think that's generally a good idea. So I had to have some kind of new statements for the JavaScript stuff. And I wanted to be syntactically conform the Python syntax, not the JavaScript syntax. Because you cannot use a new keyword in Python before a class definition or something like that. So I made it a function, simple, and it worked well. So there are two ways to instantiate objects in Transcrypt. You can call that new function, or you can encapsulate the library so that you don't have to call it. You just call the constructor. And for heavy used libraries, the encapsulation is the way to go. But for occasionally used and very large libraries, I now use Fabric.js, which is changing all the time. And also, of course, jQuery is changing all the time. I don't think you must encapsulate or change anything. You just use it as is. And then there was still one problem. That's the problem of the ambiguous keys. When I use a dictionary in Python, I can have numerical keys. I can have string literals as keys. If I call a function, it's evaluated and what it returns is used as a key. But in JavaScript, things are much more informal. If you put quotes around something, it's a key. But if you leave out the quotes, it's the same key. And if it's an integer, well, it may be interpreted as an integer, but then also can be interpreted as a string. So it's all very vague in my view as a Python programmer. So how to solve that? Well, I thought there are two groups of people who will use Transcrypt. One group, hopefully, are the Python programmers programming for the web. And maybe there are some JavaScript programmers as well that like the structure of this language. So I made another Pragma, there are several of them, so that you can locally switch between the JavaScript interpretation of keys or the Python interpretation of keys. So you can use these strict Python interpretations. You have to have quotes around a key, and a number is a number and never a string. But you can also use the loose, somewhat informal JavaScript way of working. I don't care whether you use quotes, and if it looks like an integer, well, still maybe a string. So both possibilities are available, and those were the main things, I think. Well, you have this $sign thing. I wanted pure Python syntax, and a $sign cannot be an identifier. But the aliases, the mechanism that you can replace one identifier by another, also solves that in a very neat way. So there were no real big problems in that respect.
You also incorporated the DOM API into Transcrypt. Were there any additional challenges posed by that? I can imagine that would simplify actually writing the Transcrypt code as opposed to having to always translate into Python and then figure out how that maps to DOM elements. But having it natively supported in the Python library, I imagine would greatly simplify the developer flow. But was it difficult to bring that into Python, and maybe some background on how you did that?
Well, the fun of it is that I didn't have to support it at all, since every Python function call is just translated into a JavaScript function call, and the extra mechanisms, for instance, for var args and things like the star and keyword args, they are optional. So if you do nothing special, your Python function call just translates into a JavaScript function call, which means that you can use all those DOM functions without any special measures. And also the DOM object, well, a JavaScript object is just a special case of a Transcrypt object. So you can use those JavaScript objects, DOM objects, library objects, and their methods without any special measures. So I didn't have to do much there.
It's always a good sign of proper design when things like that just happen to shake out naturally based on how the library was written.
I agree. I think a design is good when it starts to shrink.
Yes.
At first it gets bigger and bigger and more complicated, and then things start to fit together, and it shrinks and it shrinks and it shrinks. And I agree. That means you're on the right way. Yeah. Transcrypt is simple. Anyone can understand the core, and the core of it is maybe it's 6K or something like that. And well, I gave that part a lot of thought because that really matters. for instance, function calling. Halfway I got a criticism that was, I didn't like it, but the guy was right. He said to me, well, you have made this function pointer assignment, and you did that by making each function a property, but that gives a lot of overhead. Well, at first I thought, well, it's a little bit of overhead, who cares? But in an inner loop, it can be important. So I thought about that, and then I read something about memoizing, call memoizing, and I decided to optionally make functions not a member of a prototype, but directly of the object, even if they are inherited. It means that you call a function one time, then the property is replaced by the address of the function that has been looked up along the prototype chain. And next time you call it, it will be called directly. So actually it's faster than JavaScript itself in that respect. So this type of criticism, well, I like very much that people think about these things and give feedback about it, because it really makes it better.
Yeah, definitely. And you mentioned briefly that, at least in that particular case, the performance of the compiled transcript is actually better than native JavaScript code. I'm wondering, in a more general sense, how the performance compares between what you compile from transcript and what an average web developer would write in vanilla JavaScript.
Well, of course, if you're writing in native JavaScript yourself and you really optimize by hand, you can't be beaten. The same holds for assembler, by the way. You can say a program in C, but since anything you can do in C, you can also do in assembler, you can always win. But in practice, of course, you can, when you program in JavaScript, you can also search the prototype chain for once and then replace that method by a direct call. But people don't do that. And, well, with regard to the performance, I think it is in the same order of magnitude. It should be roughly equal. There are some things, it depends on which switches you use. There was the point of operator overloading. If JavaScript doesn't have operator overloading. And at first I thought, well, I don't care. But since I do a lot of numerical analysis and a lot of matrix algebra and differential equations, I wanted it in. But if you do that, every plus, if you add two integers, there will be a call to an add method, and that's unacceptable. So again, the same solution. I noticed in my own code that there are some parts where a lot of computations get done with matrices and vectors, and other parts are just simply GUI code or just using integers. So you can switch operator overloading on locally and you can switch it off again. Same holds for having keyword arguments. The keyword argument mechanism is very handy, but it's also very expensive in JavaScript. So also you can switch that on or off. So I think by that kind of measures, I haven't done a benchmark, and I probably won't do that myself because it will be biased, but I invite people to try. If I look at what type of code is generated, the performance should be about the same. And if you don't constantly use things like a variable number of arguments and things like that, or keyword arguments, I think the Python code will be about 20%. The JavaScript code will be about 20% larger. And that is the case because JavaScript version 5 that I used doesn't have things like list comprehensions. So, of course, it will be longer because you have to translate it to a for loop, but it will be about 20% longer. So I don't expect there to be any performance problems, really. And by the way, I think you should start optimize for performance too early. It's more important that you understand your program and you can roughly optimize the logic of it. And people optimizing, optimizing in minor spots. There's another Pragma which allows you to embed native JavaScript into your transcript. So if there's a point where you say, well, I'm in an inner loop and it's not fast enough, I doubt whether that's the case, but if it is, you can just insert native JavaScript at that point in your code.
And you were mentioning being able to turn on different features on and off, like the keyword arguments and operator overloading. And is that all just handled with Pragma statements in the code?
Most is handled by Pragma statements. There are generally two ways. You can use a command line parameter, which in many cases I disadvise. Of course, it's very easy to switch all the Python facilities on, but then you will have bloated code because, well, there are some things that Python can do that JavaScript just cannot yet do. Operator overloading, for instance. So to augment the compiler switches, there's a growing set of Pragmas that will enable you to switch things off and on locally. They're documented in the documentation. It's explained what they're for. Another problem that I encountered, there's a static checker on board and also a minifier, Google, what's it called? The Google Closure Compiler. And there's a static checker, and the static checker doesn't know about JavaScript globals. So whenever you use a global, I think you shouldn't, but whenever you do complain that you use something that's not defined because it cannot see the definition. So another Pragma is about telling the checker, okay, I use console, I use window, names like that. Don't bother because they are defined. They're not defined in my program, but don't complain about that. So I use that mechanism a lot.
And so how is the transpilation performed, and what are some of the methods that you use to keep the build size as small as it is?
The parsing is done by the AST module. That will be clear, because I cannot beat the native parser. It's the standard. When I was developing, I soon found out that if it was growing and growing and growing the code, and it's very simple to throw something over when you implement a new feature. So what I added in a very early stage was automated testing, back-to-back testing with C Python. That is an important part of the development process because I can add things and just run the auto test. It's included, and I hope people that write libraries for it will also auto test them properly. So the testing problem was something I had to tackle early to be able to develop rapidly. Another thing is the way code is actually generated. The AST module has methods for that. It's the visitor pattern. You have a syntax tree with nodes and you can visit it. At first I visited all the nodes as they were, but then there came some trouble in paradise because, for instance, tuple assignment is not as simple as it may seem. There are some transpilers that have tuple assignment, but it doesn't work properly. It only works for if you assign a flat tuple to another tuple, but in CPython, this may be hierarchical and nested. And you can use tuple assignment just to assign A, B is 1, 2. But you can also do this in a for loop using enumerate, for instance. And there are other places. So I found myself repeatedly writing the same code generation. And that was when I said to myself, I must not do that. If I have an assignment in the head of a for loop, it's just an assignment. So what I do is I generate an assignment node on the fly. I alter my syntax tree and I use exactly the same code generation, which lowers the possibility of errors. So I use the syntax tree, but not as is. I modify it. And that was also a rather important discovery. And there were some things where I had to try to make a wise choice. One such point was truthiness. A list in Python, an empty list, is evaluated as false. But in JavaScript, an empty array is evaluated as true. Now, it's very seductive to put all those bells and whistles in and automatically convert this stuff. But okay, what would you gain? If you don't convert automatically, you have to check for the length of an array rather than say if array. You have to say if array.length or a len array in Python. That's a minor price to pay compared to having to check anything for matching type and perform auto-conversion at runtime. So that was a point where I said, okay, truthiness, whether something is true or not, in JavaScript is fundamentally different from Python, and I will not add the mechanisms to do the automatic conversion because it will make it slow and bloated. And I don't mean it to be perfect, complete Python. It goes quite far, but I mean it to be usable and fast enough. And so that was, I didn't like to have to make that choice, but I had to.
There's a module called Asteroid, which adds on extra functionality on top of the AST. I don't know if any of the added capabilities would be useful to you or not.
I've looked into it, yes, right. There are quite some transpilers that use it. I forgot which ones, but it is used. No, I didn't feel the need for it. The AST module had enough functionality. If you look at the code generator, it's all in the distribution. It's called compiler.py. And you see that it's very simple and straightforward. It wasn't difficult. The AST module is powerful enough. I know there are transpilers that try to abstract away the version dependency from a certain Python version by making a kind of intermediate tree. But I didn't want that. I wanted to be very close to especially certain Python versions. So that's a point to consider. It is not a Python transpiler, it's a Python 3.5 transpiler. And as soon as 3.6 get out, you will have a 3.6 transpiler. Why? Well, because if you don't do that, you cannot use the new features. You have to zoom out a little bit and get a little bit vague. But no, I used nothing on top of AST. I took a look at quite some things there and I just didn't feel the need. It's powerful enough as is.
Do you anticipate any problems or excess work that comes from having to match so closely the version of Transcrypt to the version of Python that it's running on?
Well, yes and no. I hope that the revolution that took place from Python 2.7 to 3.0 doesn't get repeated. I mean, I find it very courageous of Guido that he took that step. And, I think the whole developer community, was in a shock when he did. But I don't expect any revolutionary changes in Python itself. So Transcrypt will be growing and will be in an evolutionary process. And I will not try to keep up within a week within the newest Python version. But since, it is a moving target, Python itself, if Transcrypt wants to remain, a cutting-edge product, it will have to be adapted anyhow. So I'll try to keep it in pace. I don't see it as an extra burden. The alternative would be, I make something that roughly looks like Python and I keep it the way it is right now and I freeze it. Well, that's not what I want. I expect Python 3.6 to be an evolutionary step, and in some respects Transcrypt will take that same step, and in others it won't. It will never be a complete Python implementation because that would be slow and bulky.
So, given the nature of JavaScript's prototypical inheritance and differences in class semantics, I imagine that adding support for multiple inheritance and reflecting the structure of Python classes must have been pretty challenging. I wonder if you can describe the process that you undertook and how you arrived at your current solution.
Yeah, well, it was funny. When I started out, I had the automatic misconception that Transcrypt inheritance should somehow have something to do with JavaScript inheritance. I mean, there's an inheritance mechanism there. So my prejudgment was, if I use the JavaScript addition to add, which you should because of performance, then I should also use the JavaScript inheritance to make Transcrypt or Python inheritance. Well, that's not true. You don't often inherit. You don't often encounter and interpret a class definition. So inheritance, in fact, doesn't have to be very time optimized. It has to be space optimized, but not time optimized, because, how many classes will you have in an application? 100? Well, then it means that you read 100 times to a class definition. So what I did is, at first I started out using JavaScript inheritance, and it turned out to be hard and clunky and artificial. So then I said, I won't use it at all. I will just try to implement Python inheritance in JavaScript. So I just copy the methods, the properties, things like that. And you really need to have a lot of freedom there, because implementing properties, was difficult enough in itself without bothering about JavaScript's prototypical inheritance. So I just bypassed it. And one good idea was, at first I thought a class should be an object. But since you can call a class to instantiate something, I discovered that a class must not be an object but a function. That was one step. And another step was indeed to say, what do I need in Python for multiple inheritance? I just write it out in JavaScript, and then it turns out that it's still very compact. If you look at the core module, it's called _core_dot_mod.js. Then you see that's only a few K of code for everything, including multiple inheritance. So it took quite some thinking, but in the end, it turned out to be very simple. The biggest step was to let go of JavaScript inheritance. You cannot use that. It just gets in your way.
So what aspects of the Python language were most difficult to translate to JavaScript?
Well, two things, I think, yes. Well, one thing I couldn't translate, that was the truthiness, the automatic conversion. It would be too slow, so I let go of that. The other two things that were hard, one was the keyword arguments. I really had to think very deeply, and still it is, it takes a lot of JavaScript code to implement that, so you had to make it switchable. You switch it on only for a function that you expect to call with keywords. That was one point. And the other point that was hard to implement was the operator overloading. It's not hard to implement, but it's hard to do it properly without hampering your performance. Oh yes, and of course one thing I almost forgot, because it was very early in the process. I wanted to be able to assign a method to a variable. So it should be a bound method, which means that you have to implement somehow the descriptor mechanism. Well, that really was very hard, and I think I had some sleepless nights over that, but in the end it worked out.
You mentioned that you don't anticipate much difficulty in keeping up with different versions of Python, but what about when the newest JavaScript standard, the ES6, is more generally used and widely supported in browsers? Do you anticipate a lot of work necessary for updating Transcrypt to leverage that syntax, and then also given that the JavaScript spec is intended to be updated on a yearly basis going forward, I'm wondering if you anticipate a large body of work necessary to maintain compatibility there.
Yeah, well, on one hand, programming is always a lot of work. It seems simple if you think about it, but if you have to implement it, it's still a lot of work. I expect it to be doable. For one thing, I will not switch too early to JavaScript version 6, because indeed, as you say, it has to be available on many browsers. If you want to make websites using that, you have to be sure that your clients can understand it. But I see some developments with JavaScript, comprehensions, for instance, and some other stuff that it makes it attractive to make the switch, but it will be an option. It will be a command line switch or another Pragma. I don't think it will be a lot of work because, once JavaScript will support comprehensions, array comprehensions, compiling list comprehensions will be simpler. And what you see is that JavaScript is in a process of keeping up with some good Python ideas, modules, things like that. And my father used to say that a camel is a horse designed by committee. I think that's happening with JavaScript. In the end, everything will be in, as is the case with C++, but it won't have that simplicity. But I have the idea that the newer features of JavaScript are converging with Python. But what I'm afraid will never converge is the prototypical inheritance. And, it's totally subjective. I know that there are people who dream in JavaScript, but I can't get my head around it. I understand how it works, but it doesn't fit my way of thinking. So it will JavaScript and Python will converge, which will make it not too difficult to compile for newer JavaScript versions. I expect that not to be very much work. It will be an option for a long time, and I don't expect JavaScript to be at one point so good that the Python community will switch to it, because the power of Python is that it has been designed, I think, and it's guided by one man, and that keeps it kind of unified. And Transcrypt I hope it will be a community thing. I hope it will be used by many people. Currently, some of my students are writing libraries for it. NumPy is high on the wish list, and it should use the graphic card for computations. Another thing is matplotlib, but I'm afraid that will be hard to do. But what I plan to do, I will not develop everything myself, but I plan to keep my hand on the wheel as well, because I noticed that people make demands for all kinds of features, and it's easy to make it grow in every direction, but it should stay a bit focused. And so I won't have to do all that work myself, I think. I hope it catches on. But I will try to control the direction it moves in, because I want it to stay lean and mean.
So is Transcrypt complete and stable enough to be used in production?
Yes and no. I use it for production, and I think I'm a lot happier with it than programming in JavaScript. It's quite stable, but to be honest, it's an alpha version, and it will remain an alpha version until it's, really stable. So I hope people will give feedback, as some people do. I cannot test everything myself. I mean, the auto test is there, but people come up with uses that I haven't thought of. So even as it currently is, I prefer it for my own commercial projects. I prefer it above JavaScript. It is quite well tested, quite stable. But there will be some corpses in the cupboard as well. There will be some things that are really wrong and I just never bumped into them. I hope people will report. I expect it to be in alpha for another few months. And, hopefully the quirks will be out. There are no showstoppers in right now, as far as I know. I didn't write it in such a way that I first made it very clumsy and thoughtless, and then I improve it or something like that. I like to try to do it right the first way, but of course it's work of a human being, so there will be problems. I haven't run into any right now. I don't know of any bugs, but if people start testing, they will come up with things. I'm convinced.
So you were mentioning how you've had people requesting porting things like numpy and matplotlib into Transcrypt, and it seems that the C extension portions of those would be difficult to be able to support in a JavaScript environment. So I'm just curious if you have any thoughts on that matter.
Yes, I have. I won't go the ASM.js way, but for NumPy, as I said, one of my students is currently studying at the Delft University is looking into that with a friend. What I would like to do for NumPy is use the graphic card. So, when you use your GPU, you use your card for computations. It can be about 30, 40 times faster than even when you program it directly in C++. So C++, no, I don't see that happening anytime soon. Because if that would be possible, if it would be possible to have efficient code in C++ running in the browser, Transcrypt would be not necessary at all. We would just run CPython. But I don't see that happening anytime soon. But I think that using the graphic card is one way to go. Using ASM.js is another way to have efficiency and maybe even run some C code where necessary. But, I accept the fact that the browser world is dominated by JavaScript. So suppose you use ASM.js, you can probably make things that are very efficient, but they are also very unreadable. And people want to debug and they want to understand their code. I don't think there will be much C code. I think there will be fast code, probably on the graphic card, but not much, no C code on top of ASM.js. I don't expect that to have much advantages.
So are there any questions that I didn't ask that you think I should have, or anything else that you want to bring up before we move on?
Well, I think your questions were quite good, and we had a good view on what Transcrypt is. But I have a question.
Sure.
I think technically this is rather good, and anyone judge for itself. I won't run. I have had a request for benchmarks, but I won't do that because it's so easy to skew them, to use a piece of code. Transcrypt is very good at. I also don't want to say this is the one compiler to end it all and to replace other compilers. But what I would like is for people to take a look at it, judge it on its merits, and give feedback. Because there are a lot of people starring on GitHub, and there are a lot of downloads on PyPI, but I get too little feedback. I need input to be able to test it, and what it needs most, and I have no idea how to do it. I hope this interview helps, and thank you for that. But what it needs is mindshare. If people start to develop serious things in it, and they start to invest money in making applications with this, it must not go away. Well, what's important in that respect, I don't see it as my property. I see it as my baby, that's true. But, my children are also not my property. And, Transcrypt isn't. I will keep a hand on the wheel. But this is open source. It won't go away. It can't go away. Anyone can fork it. If you look at the source, it's simple. So somehow, I don't know how to make that happen, but somehow I hope it gains mindshare and people gain trust in it. I've been a developer ever since I was 15. I'm 57 now, so you can know how long that is. I still service software that I made 30 years ago. It's still used and it's still okay. So what I would like to say is this is really serious. It's not going away. It's not a hobby project. I will try to involve more people, and it's open source. I hope people will use it.
Yeah, I think that's very reassuring hearing you say how it's not a hobby project and it's something that you consider a serious piece of work, because I know that a number of the other Python to JavaScript transpilation libraries are seen more of from an experimental perspective and not really intended necessarily for production everyday use. So I definitely think that that's another point where Transcrypt kind of stands out from the crowd.
It is for production work. I program for a living, and I'm programming medical imaging. That was my problem. And I wanted to run stuff in the browser, and I couldn't in a way that was acceptable for me. So for me, it's very serious. It's part of a multi-year project where many people are working on. And, I just thought this is usable. More people can use it. But indeed, it is very serious, yes.
So for anybody who wants to follow you and get in touch with you and keep up to date with the things you're working on, what would be the best way for them to do that?
There are some ways to do that. There is the Transcrypt site, www.transcrypt.org. There's a forum where it's still very quiet because who wants to be the first? But there's a forum. You can reach me there. On PyPI, there's my email address. You can reach me there. And I like to have feedback, so feel free to send an email or to enter the forum. I will react. I will not blindly implement any feature that's requested, because then it would be bloated. But approach me by email, for instance, or on the forum, and I will certainly react. And that's the way to make contact about what your wishes are. And I invite you to write libraries for this, because I will not do that myself. I will try to make the core as good as possible, but I hope people will start writing libraries.
Okay. So with that, I will move us on to the picks. And for my first pick today, I'm going to choose the cookie cutter library. I've just started doing some more work in SaltStack for my job, and I ended up writing a cookie cutter template for being able to easily generate the directory layout and some initial files for SaltStack formulas. So it definitely is saving a lot of time in that respect, and making sure that anybody who is leveraging that inside my team is starting from the same point. So definitely very useful for that. And I'm just going to leave it at that today. So Jacques, what do you have for your picks?
I have something, and it's meant especially for the Dutch audience, but also for a broader audience. I've been programming all my life, and I learn something every day from my students. And I think, well, there's a lot more to programming than is taught in the educational institutions. So I'd like to invite young people to dive into this and, well, not be shied away by all the jive talk around it and all the design methods and things like that. Programming in itself, I've done it all my life. It is fun. It is rewarding. You can earn a living with it. And well, I know it isn't a popular thing to say among managers, but it's really an art. I like my code to be beautiful, and programming is fun. So I just want to invite people to be a programmer and to take pride in your job and try to do it properly.
Well, Jacques, I definitely appreciate you taking the time out of your day to tell me and my audience more about Transcrypt. I'm sure that there are a number of people who are very interested to test it out, and hopefully you can get some feedback from that. So thank you again, and I hope you enjoy the rest of your evening.
Oh, thank you very much for giving me the opportunity to expose this to the public, and enjoy your day. Bye.
All right, thank you. Bye.